So we're spinning down our mini preps. We've used the buffer P1, P2, and N3. We then shook everything up and we crashed everything out and it's spinning. So I just want to rehash the entire process from the beginning just to make sure everything's crystal clear. So we start off with some overnight culture and it's in a 24 well block. We take that block, we make a balance, so that means we weigh it, we make another 24 well block, fill it up with water so they weigh the same, and then we spin them down for 3 seconds. We then get a 24 well block. Each well that had culture in it now has a pellet and some supernatant. So we go, we ditch that supernatant, we throw it into some bleach water, and we dry it off, we tap it down on a paper towel, and then we end up with a 24 well block, and the cultured wells that originally had culture in them now only have a little pellet. Then from there on, it's pretty much the same as a regular mini prep as far as the buffers are concerned. We use 250 microliters of P1. That is the resuspension buffer that just takes your pellet and once you vortex it and makes a resuspended version of your overnight culture. Then we add the P2, and that lyses everything. You need to be very gentle when you do that lysis step. You do a very gentle rock to make sure that you don't shear any of your genomic DNA. After that, we're going to use 350 microliters of N3. That's crashing out all of your junk, all of your genomic DNA, all of your cell walls, all of your membranes, all of the protein. That's all going to get crashed out. And you're going to start out with a gentle rock, but then slowly get more and more vigorous with that N3. You're going to start to shake it as hard as you can without splashing everything all around, because that might lead to contamination. After that, we're going to spin it down for 10 more minutes. That's what's happening right now. After that, all of our junk, all of our white junk that the N3 precipitated out is going to be pelleted, and we're interested in the supernatant. And from there, we're going to start putting the supernatant over these columns. So while we're spinning, I'm going to start to prep this. So these are just this blue thing is what we call a vacuum manifold or a pig, and these are just regular mini prep tubes. Normally we put them in our little, I guess, spin waste things, I forgot what they're called. But for here, we just stick them in these little holes, and however many samples we have, we get that many tubes, put them in the holes, and then we take these little plugs and fill up the rest of our holes. That way, when we connect this to a vacuum, it's going to be sucking through all of these little columns. So we're going to be attaching our vacuum line to a vacuum trap. So vacuum goes into this flask, and then it pulls the vacuum, and then this thing goes around. Hopefully you can see that construction, so that if we pull up any liquid, it gets caught in there instead of going into the vacuum system. So when I turn on this vacuum, it creates a vacuum here, which then pulls all the air out of here. So next thing I'm going to do is I'm going to close all of my tubes, and I'm going to label everything. And this is also a good chance to make sure that all your your columns are nice and solidly inside of your vacuum manifold. So my tubes are going to be 1 through 8. So 2, 3, 4, 5, 6, 7, 8, and then T1, T2. T3, T4, T5, T6. Then we can just open these back up. And I'm doing all this prep right now. I always do all of my prep for the next steps right now, because you have 10 minutes to kind of get everything set up. So we have 14 samples, and I'm going to get a block and get my 14 elution tubes all set up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we can just do the same thing, just put them all in your rack and get them all labeled up. So, cap's facing the right way. Cap them. then we're going to label them. Again, use a lab pen. Don't use a Sharpie. Sharpies will just come right off with alcohol, and some of the buffers we're using have alcohol in them. So 1, 2, 3, 4, 5, 6, 7, 8. You may want to use a more descriptive labeling than this, but for now we'll just stick with that. So we have T1, T2, T3, T4, T5, T6. And then we can just get our flow-through columns ready, which are hiding from me. We just need to get the same amount. So what's going to happen is we're going to put our supernatant through here, and we're going to flow it through, and then we're just going to wash with our buffers right over there. So that's going to be buffer PB and buffer PE, and then we're going to take our columns out, put them in these waste reservoirs, and spin them out to dry them before we go on to the next step. And from here, we're pretty much ready to go. So all we need to do is get our buffer PE and our buffer PB. Let's see, where's our buffer PB? Buffer PB. So we're going to do one last review just to kind of hammer this into the ground. So we start with our 24 well block that has culture in it. We spin it down for 3 minutes at 5400 and S5700 rotor. We then ditch the supernatant. We put in 250 microliters of P1, which needs to be kept refrigerated. We resuspend that on the vortex. We then put in 250 microliters of T2. We gently rock that on the table. We add 350 microliters of N3. We start with a gentle rock. We get more and more vigorous to make sure that the stuff that gets crashed out is broken up finely. If we don't do that, we're going to have membranes separating the N3 and the rest of the lysate. After that, we're going to spin down for 10 minutes. That's where we're at right now. And then we're going to go into the column portion of the prep, which involves putting our supernatant over the column, washing with PB, washing with PE, taking our columns, putting them into the waste reservoirs, spinning them for 2 minutes to dry, and then the elution step. So we'll be back in a couple minutes to show you what this actually looks like.